over -4. Notice that's the ratio of the leading coefficients.
Right, yeah.
And you do need to reduce. So this case would be -1/2.
Yeah. Oh, okay.
So you're looking for something like that.
Mhm.
And then -2.5, something like that.
Yeah, got it.
And that's probably all the guidance you need. It's going to always be the ratio here in this case for the horizontal. It's no longer 0.
Right. Okay, I just entered that in. It said it's incorrect. I think I graphed it correctly. Oh wait. I'll just share my screen. Because this is the half, and then this is 2.5.
I'm sorry, it's -1/2. I graphed it in the wrong spot. I'm sorry. So then that horizontal one needs to go down to below the x-axis. Right
Here.
there. Yeah. That'll take it.
Okay, I guess I can just try the next one.
Okay.
So just so I have for the vertical asymptote, that's going to be -1.
Yes. Yes.
Here.
There it is.
And then we have like 9/3. So would it be just +3?
Yes. Y = 3. So up 3 on the.
Okay.
Looks good.
Cool. And this one. So x is 7/2 for the vertical asymptote.
That's right. So about 3.5.
All right, here. And then this reduces to -3.
That's right.
Okay, like this. Okay, perfect. Okay, I got that. Okay. Trying to see what other ones. I think there was. I guess we can do this one because I was kind of stuck on this.
Okay. All right. So this trying to think of a good explanation here. So the letter D is a polynomial, the last one.
Yeah,
Because it's got integer powers. And I'm sorry, whole number powers. So like 8 and 4 are positive and they're nice.
right.
Okay. Now when you look at letter A, you might think that that is also a polynomial because it's +6. But if you were to bring it into the numerator, it would be -6.
Which we don't want. So
yes. So that's no. B doesn't have any x's, but it is a polynomial because it's just a number. That's okay. And C looks good until you get to the square root of x, which is a restriction. It's x to the 1/2 power, which is obviously not an integer. So that would be a no for that reason. Okay.
This is no because it's a negative.
That's right.
This, if you factor this out, this would be.
Yes, it would be nice if you multiplied it out.
Mhm.
How about C? It's like letter A in the previous one, the 1/x to the 6th. So since x is on the bottom, that's bad.
So we don't. It's not a polynomial.
Yes.
And this one look.
So square root means x to the 1/2 power, and that's bad. It has to be a positive number in the numerator.
Okay, I'm gonna write that down. Okay. This is a polynomial.
Okay, agreed.
This is not.
Agreed.
This is also not.
Okay, I agree.
And this isn't because we have a negative.
That's right.
Okay. Okay, I'll remember that. Okay, that I can do my own. I'm trying to figure out like what I not good at. Okay, let me just do this one.
Yeah, this is one that you struggled with, so it might be good to look at.
Yeah, or this one
This
too.
this one good. Yep, these are all
Yeah,
good.
I'll just start with this one. We can do the next one after.
Okay. So I would start with letter B.
Mhm.
B is asking for the X value.
And then the minimums are the Ys.
Yes, yes, and it's just kind of odd. So to me, it's at that 4, -2. Is that the ordered pair? That's the minimum.
Mhm.
So the X value there is 4. And then the Y value is -2. It's like,
Two.
where's the minimum? And then what is the minimum?
Okay.
So, so
Okay.
that A is -2.
-2.
Yes.
Oh,
Okay. All right. So I let me step. So that's actually asking for more than that. So let me grab
okay.
this, and I'll just provide a little more commentary on it. Okay. All right. So there's actually, let me let this load. There's actually 2 local minimums.
Okay.
Let that load up here.
Mhm.
So it's like hiking. This is a minimum, and this is a minimum here because they're
Like the
smaller
lowest points, like the dips.
than their surrounding areas. So
Mhm.
they're, and they like, again, this is the X, this is the Y.
Right.
So it's at -3, 4. And then what is the minimum at those points? It's 1 and -2.
Oh, okay, okay.
So you're essentially putting in both X and Y. If this were asking for a max, it would just be up here.
Mhm.
So local just means it's relative to its surrounding areas.
Okay. Okay, I'll just share my screen again and then.
Okay.
So this one's asking. So these are maximum values. So it'll
Yeah.
be.
So there's just one this time. Because local max means higher than its surroundings.
Mhm. So
And
this is, wait, so this is the X. Wait, look, wait, no. This is the Y.
that's the Y. Yeah.
So that would be 2.
Yes.
Yeah, we had 2. And then this would be the X, which is just -2.
That's right.
Okay. And then again, this is maximum.
So this one has 2 maximums.
So 1 would be 1. Or wait, no, yeah, maximum. So
So the maximum, like I ask it differently than this, than the way they're asking it. Just to be clear, letter A is asking for the X values.
the X values, which is -4 and 4.
That's right.
And then
And then
the
B is,
local is
what is
Y.
it? Yes.
Yeah. Okay. Okay, I'll make note of that. Yeah, I think I just mix up the Ys and X's.
It's very easy to do.
Yeah. There's trying to find the other one that came right after. I think there's some at the end that I got stuck on. Okay. Wait, that I know how to do. Yeah, these ones are, I remember I kind of struggled with these.
Okay. Yeah, there's a lot here to do these.
Yeah.
All right, let me grab a snip of this and talk you through it. Talk through it. All right. Okay, so let that load up here. So vertical asymptotes, you set the bottom equal to 0, x squared minus x minus 6 equal to 0, which means you have to factor this.
Right.
And depending on how good your factoring is, this could take a while or not. So there's those 2 factors. Do you need me to go through factoring?
No, I got it.
Okay, so then you set each of those equal to 0.
Mhm.
And those are the two vertical asymptotes.
Oh, okay.
There's one at 3 and there's one at -2.
Okay.
All right.
Mhm.
The horizontal ones is actually much closer to what we did previously. It's an equation y equals. Now, the number that goes up top is the 1 that's in front of the x squared.
Mhm.
And the number that goes on the bottom is the 1 that's in front of the other x squared. So
Mhm.
keep in mind, like it could be like 2x squared, or it could be 3x squared on the bottom.
Right.
This does reduce to just 1,
Just one. Mhm.
y equals 1. It doesn't always, but it does obviously in this problem. So
Okay.
this is everything that they're asking you to do.
Okay, gotcha. Okay, I can attempt the second one.
So of course this one's different.
Oh, okay.
Um, yeah, let me, well, yeah, I better grab it.
Okay.
All right, new share. It's the same steps like you do for vertical asymptotes here. Let's let that load up. You set the bottom equal to 0.
Mhm.
But when you do it this time, you get minus x squared equals 7, x squared equals -7.
Mhm.
And this is no solution. There's no situation where you square a number and get a
And
negative.
that's negative, right?
So there is no vertical asymptote
Okay.
in this one, but there is a horizontal. Okay.
Mhm.
And it has to do with, there's really an x to the 0 here in the numerator.
Mhm.
So when the degree of the numerator, which in this case is 0, and the degree of the denominator, which in this case is 2, when you have the numerator less than the denominator,
Mhm.
it's always y equals 0.
Y equals 0.
And
Right.
that's what we were seeing in the first grouping of questions.
Mhm.
So if I were to just scroll up and look at those, I think I had one snipped in. This is the same situation: x to the 0, x to the 1. 0 is less than 1. That's why it's y equals 0.
Equals 0.
But then the ones that we were looking at here, see how these have the same degree, basically x to the same power.
Mhm.
That's why it's a ratio.
Oh, okay.
So there's a couple of different rules too, and I can summarize them if needed at some point. But
Mhm.
for this one, no vertical asymptote, just a horizontal at y equals
Mhm.
0.
Gotcha. Okay, I'll share my screen again. Okay, I guess
This one's more like kind of like the first one. You have to
Mhm.
set the bottom equal to 0.
Right.
So I'll let you do that.
Mhm. So you get x is 1/2.
That's right. And that's the vertical one.
0.5. And then
So for the horizontal, there's the degree of the numerator is greater because it's 2. It's greater than the 1. So there
right.
is no horizontal asymptote in this case.
Oh, okay.
And there's actually a slant asymptote, which you can check that. You'll see later on.
Okay. Okay, let's see. Okay, honestly, yeah, let's work on this one.
Okay, let me grab a snip of this. I think the challenge here is the fact that it's asking about the domain as well.
Mhm.
All right, so the first one here, let's let that load up. There it is. F minus G. So you take that f of x as is, but
Mhm.
when you subtract the other one, it's really in parentheses like this.
Right.
And the reason that's important is because you're going to distribute that negative to both terms.
Mhm.
So it's gonna be minus 4x plus 3, 3x squared plus 5x. And then you combine like terms. So in this
Mhm.
case, it's 1x plus 3.
3, right.
Okay, so that's there.
Mhm,
The domain, basically, it's like, are there any restrictions on the two original ones?
mhm.
And there are not. Like, what you're looking for with restrictions are division by 0 and square roots. So neither of these have restrictions, so it's everything.
And why don't they have restrictions?
So the only time you're looking for restrictions is if you're like dividing by 0, something like that would have a restriction whenever x, or like the square root of x.
Mhm.
Those are the ones you have restrictions with.
Restrictions for- Okay. Okay, I typed that in.
Okay, now for the other one here, you're multiplying. This one's got more work. Minus 3x squared plus 5x times 4x minus 3. You do have to FOIL this,
Portal, yeah.
and we'll do that here. So minus 12x cubed plus 9x squared plus 20x squared minus 15x. And I think I did this, maybe I did do it in the right order. So then you combine like terms if possible. Minus 12x cubed plus 29x squared minus 15x.
Mhm.
And that's your answer. And again, the domain is minus infinity to infinity.
There's no restrictions. Okay.
Yeah, there's no issues with them, and then multiplying them. It's really only if you end up dividing, you might see a problem where it's f over g. That's when we're going to probably see an issue.
Okay.
But we shall see, as someone once told me.
I entered in something wrong.
If you want to share your screen, I can
Yeah,
look.
for
I
the
mean,
first equation, yeah, I think it says, because wouldn't 1x just be x? I mean, I don't know if they're that specific.
oh yeah, I'm sorry. It should just be x.
Yeah.
3x squared plus x.
Oh. Plus x.
Oh, there was a negative. It was negative 3x squared. I didn't copy that down right.
Oh, I didn't write that down either. Yeah.
So that is why it didn't like that one.
Gotcha.
All right, this one has issues. So I'll grab a snip of this. Division. Whenever you see division, you know you're in for some problems. So, all right, let me share my screen. I'm going to do, well, I guess I'll do them in order. So f times g of x. So that's 1 over 5x squared plus 3 times minus 3x squared plus 4. And then when you're multiplying them, the number, this thing in the top just stays in the top, thing in the bottom stays in the bottom.
Right.
So it's minus 3x squared plus 4 over 5x squared plus 3. That's your first answer. Now, I mentioned a couple times now, like the only issues if you're dividing by 0. So the question is 5x squared plus 3, like, can that ever be 0? And you will find that it cannot. If you set it equal to 0, when you subtract 3, you get 5x squared equals minus 3, x squared equals minus 3 over 5.
You
Not
don't need a
possible.
negative.
Yes. So that's everything. So, a little deception is like, oh, can we do it? Now, when you add them, 1 over 5x squared plus 3 plus minus 3x squared plus 4. I think you can just type this in. I don't think you have to find a common denominator. Not sure. But it is there again, there's no restrictions because neither of them individually have restrictions.
Right. Yeah, let me type that in and see. Should I put a 1 over the or under the negative 3x squared over 4?
You should not have to, but it could want us to make a common denominator here, which is more work.
Mhm.
I'm not sure. It did not like the answer.
Okay, let me see. I'm just gonna type it.
You should not have to put a 1 though there. I think
Yeah.
the previous problem would have been okay too. It was that negative in front that it wasn't checking out on.
Yeah, let's see. Oh yeah, it worked. Yeah, I don't have to put a 1 under it. Okay, I'll share my screen again.
All right, so grab a snip of this. All right, here we go. So the first one is to multiply f times g of x. So
Mhm.
that's the square root of 2x plus 1 times parentheses 3x squared plus 4. And there's nothing to do. Like you could multiply, but it doesn't change it. So I believe it will accept this.
Is that right?
Now for domain, we finally have an issue with f of x. Okay, so
Mhm.
the square root, the thing under the square root, the 2x plus 1 has to be greater than or equal to 0. And the reason is because you take the square root of 0 or positives. So,
Uh-huh.
so when you solve for x, you get x greater than or equal to minus 1/2, and that's your domain. It's from minus 1/2 to positive infinity with the
Mhm.
parenthesis.
Mhm.
And the idea is you just can't do anything less than that because you got a negative inside
Right.
square root.
Okay. Okay, I got that in.
Now for f minus g, it's the square root of 2x plus 1 under parentheses minus in parentheses 3x squared plus 4.
Mhm.
And you distribute that negative to both. And I think it does want you to do that. So your
Mhm.
answer is 2x plus 1 under the square root minus 3x squared minus 4. And then your domain is the same because you still have this issue with the square root 2x plus 1.
Right. Okay. Okay, I'll share one more time. Or I can try attempting it. Okay.
Yeah, up to you. I can look at these. Although part B is gonna have another restriction. Okay, yeah, just go and at least do part A. That's not too
Okay.
bad.
Yeah. Okay, so. So this you can't really do much, so you would just write it as uh like this.
Minus 3x plus 4 minus. Yep, that looks good. So
Yeah.
the domain is restricted by the square root there.
So I take it out of the square root
That you set the 4x plus 5 greater than or equal to 0.
to 0. So I have x is negative 5/4
Yes, negative 5/4 to infinity.
to infinity. Like that.
Good. Okay.
Okay. And then this one is division. So
Yes. So you're literally just putting that whatever's in F on top and whatever's in G on
right.
the bottom. There's and the domain's got a little modification what you have in the previous one, but
Mhm. Well, I think I because I just did it by the reciprocal. So I have it written as
It's just the f, so it's just minus 3x plus 4 up top over. So I would put
Okay, because you
and put
can't solve it.
yeah, put a fraction bar in first.
Right.
Well,
It's 4. And then x like that.
that looks good. Now the domain you would think would be just like the one in the previous problem,
Mhm.
but at minus 5 over 4, it's 0 on the bottom.
Okay.
Let that sink in from like it ends up being the square root of 0, which is bad on the bottom. So you exclude minus 5 over 4. It just changes it from bracket to a parenthesis
Mhm.
because it just can't be that value, minus 5 over 4.
Minus 5 over 4. Oh, so how would I write that, with parentheses?
Just parentheses, yeah.
And then it would go to oh wait, shouldn't be there. To infinity,
Yeah, there it is too.
like this.
That looks good.
I gotcha. Oh,
Oh no, why does this happen? What
yeah.
did it not like? F minus G? Oh, it's 4x plus 5 inside parentheses, not minus.
That was my mistake.
Yeah, and these are so bad.
That was my bad.
Uh,
Okay. Okay, I'll try this next one again. So the first one is just. Does it matter what order I write it in?
it does not. I would just follow the order though, like that. Yes.
And then.
So does this have a restriction? Is the square root restricted?
Yes.
Yes, you have to set that inside part greater than or equal to 0.
And then yeah, so now I'm at negative x squared equals negative 5x. So from
Not just the part with the square root, the 4x plus 1, you're setting greater than or equal to 0.
the numerator.
Yes.
Yes, that's plus. So it's negative 1 over 4.
To infinity, yes.
To positive infinity.
Parentheses around the on the right there. Infinity always goes with parentheses. So it's bracket on the left and then
Infinity on the.
and then parentheses on the right. So this one you're just multiplying them, but it's similar to the previous one. There's nothing to multiply. You're doing your that'll be for the next one.
It's not letting me type that. It's not letting me push X. That's annoying. 4X.
So maybe to put it in parentheses first.
Yeah, my X key still isn't working.
I try typing it in another window or another like thing. Just type in like 4x plus 1 and copy it over lowercase x. And just see if you can copy that in.
Okay. Oh, I have to put the square root first. There.
And then times minus x squared plus 5x. Now the domain here is restricted just like in the first part. Because so this one's exactly the same. There's no division, so it's not like the previous problem. It's just it's the negative 1/4 to infinity. Yeah.
Well, I guess we could just do something simple because some of these I get stuck on.
Sure.
So
So the idea is like if there's a mirror on the x-axis,
Mhm.
the horizontal, that one has it. But it's the same top and bottom.
Mhm.
Y is the same left and right.
Right.
And then origin is a rotation. Like if you literally could rotate it 180 degrees. This one has it.
Yeah.
Okay. So by comparison, graph 2 does not have a reflection over the x or the y or the origin. It's got nothing.
Mhm. And this one is the origin.
It is the origin. Yeah. Origin only.
So this is the same as the last one, I'm
That's
assuming.
right. Yes.
And then, so okay, this is the x-axis, so it can't.
It's
So
not
what-
the x, but the vertical one. Yeah, the y is looking pretty good.
Oh, because it's reflected over here.
Yeah, it's like looking at yourself in the mirror, in a
Right.
mirror, vertical mirror, horizontal mirror.
And then this one is origin.
It is.
Yeah. So this is reflected over the like x,
That's right.
and then this is x, y, and origin.
Okay, looks good.
This is origin.
Yeah.
Sure. I'm gonna find some other one I got stuck on. Oh yeah, I wanted to review this one because I know we had worked on it before.
Okay, let me grab a snip of this and all right, so we're gonna have to look at these kind of one at a time.
Mhm.
So we'll look at A. So A says to take whatever G is, which is 1
Mhm.
over 2x, and put it in for x in the
Mhm.
first one. So we're going to take this 1 over 2x and put it there for x. So this
Mhm.
becomes 1 over 2 times 1 over 2x,
Mhm.
like that.
Right.
And then you have to simplify. So this is really a fraction, 2 over 1. So it's 1 over 2 over 2x,
Mhm.
which is 1 over x, because the 2's cancel.
Mhm.
And then you end up multiplying the top and bottom by the reciprocal.
Mhm.
And on the bottom, everything cancels and you're left with just x in the
Right.
top. So that's really a good start. So if they both equal x, then they are inverses of each other.
Uh-huh.
So this one you have to go the other direction. You have to take this f of x now and put it in for that one.
Mhm.
But do you see that it's the same? It's
It's the
exactly,
same thing, so why would you do it again?
yeah. So
Yeah.
this one we check the box there. Okay.
Mhm.
And kind of similarly, the one on the right is also that, but we'll do it for this first one. So take g of x, put that in for x.
Mhm.
So it ends up being x plus 6 plus 6,
Right.
which is x plus 12. That's what
12.
goes here.
Mhm.
And then you can see similarly, okay, you
It's
get
the
this,
same
it's
thing,
the same thing. Since these are not both x, they are not
not
inverses
inverses.
of each other.
Gotcha. So only when x is the answer, they are.
They have to
If
both be
it's-
x.
Okay, gotcha. I'll share my screen again. So,
So try the one on the right first, because that's
Mhm.
gonna be easier
Yeah.
for you.
Mhm. So 6. So that's 36x.
That's right.
both.
And then it doesn't,
And they're not inverses.
they're not inverses.
Mhm.
So let me share my screen for the other one.
Mhm.
All right, so for the other one, you're taking this right here
Mhm,
and you're putting it in for x. You can see it now. So it's 2 times x plus 7 divided by 2
mhm,
minus 7. So this the twos actually do cancel.
mhm. So it's just x plus 7.
Yes, minus 7, which is x. That's good, but that does not guarantee the other direction. So you want to be really, really careful here with
Mhm.
that. So for this other one, you're taking this right here and you're putting it in for x. So it's in the numerator here, 2x minus 7 plus 7 over
Mhm.
2, which ends up being 2x over 2, which equals x. So this
Right.
one, these are
They
apparently
are
inverses of
inverses.
each other.
Right. Okay, I'll share my screen again. It's this one.
Okay, why don't you try them both here? I'll snip this in and work them out as well and just confirm your answers.
Yeah, okay.
Are you doing the one on the left or the right first?
I'll do the left first.
Okay.
So I have that these are inverses of each other.
Looks like they both equal x, yes.
Yes. And then I think I made a mistake with this one because
Which one? The one on the right?
I'm on the right. Yeah, when I'm
Okay.
just plugging this one into that one.
So for the f of g of x, it's going the other way. You're putting the 2x plus 1 in the
Mhm.
top one.
Yeah. Wait, so for this one, I have x.
It is x.
And then this one, I think I did something wrong.
You do also get x.
I think when I let's see,
So you
when I put
don't.
this into this back into this equation, I think I just distributed it wrong.
Oh no, I'm sorry. Yeah, let me share the screen, I guess.
Mhm.
All right, so get rid of this here. Okay, here we go. Okay, so the next one here, when you're taking the right here, when you're taking this x minus 1 and plugging in there, it's 2 times x minus 1 over 2
Right.
plus 1.
Mhm.
And these twos cancel.
Yeah, so it's
X minus 1 plus 1, which is just x.
x. Oh yeah, I wrote that. I just got confused because I wrote x equals 0, but it doesn't. It's just x because the yeah. Okay. Okay, let me try to squeeze in like one more problem.
Sure. Go ahead and share your screen whenever you're ready.
Yeah, let me find it. Well, there's just one specific. I can't find it. Oh, I can't find it. Oh, gosh. I think it's this one. Yeah, okay, I'll just squeeze in this last one. Yeah, just simple, like domain and range.
Okay.
So,
So this one has no restrictions on its domain. That's because it goes left forever and right forever.
mhm. So would that both be parentheses?
Yes, because it's gonna be minus infinity to positive infinity.
And then the range is the y.
Yeah, so it starts in terms of like how far down it goes down. So you want to go min to max, like bottom to top.
Mhm,
So it's gonna be parentheses minus infinity because it goes down forever.
mhm.
Up to now the max the what's the biggest y value? What's the max y value?
You have -2.
-2. And it's a bracket there because it includes that.
Gotcha.
So if you,
I think I have to just like
yeah, you have to go yeah, that's the right one.
to -2.
Yes.
Then this one, domain is just negative infinity to
Yes.
positive. And then the range would be, this is the lowest, which is -3. Sorry.
The minimum y value.
The minimum y is sorry, wait,
What's the smallest y value?
smallest.
0. See how it touches right there?
Oh, right, because it's on
So
the
it's
line.
so this one's a bracket at 0 starting out,
Mhm.
and then a parenthesis on the other side. Yeah. So it's gonna be 0 to how far up does it go? Goes up to infinity.
The range, yeah, this one says this. And then the y here is 1,
That's right. So that's the smallest y value.
which is -1 to infinity.
No, hang on. It's parentheses. You've got them flipped. So the number gets the bracket, and infinity gets the parenthesis.
Why does the number get the bracket? Because it's
Because it basically actually can take on that value. Like it actually can be 1, but infinity is a destination.
mhm. Oh, that's why parentheses, right?
Yes. There you go. Oh wait, it's not -1. It's +1.
Right, that is my mistake. Yeah, that was my mistake. Okay.
I think you also had them reversed. So like
Flipped, yeah.
do the domain first, minus infinity to positive infinity.
And then the range for y is 2.
So you start from the min though. The min is down at minus infinity. Like it goes down forever.
So wait, okay, I'm a little
It's always bottom to top. What's the bottom most
like
y
right
value?
here.
Yeah, negative infinity.
Negative infinity
Goes down forever. So you want to, it's a parentheses.
first.
Yes. And then what's the biggest y value that I can take on?
2.
Yes. Okay, one more here, get the full point.
So domain is negative infinity to positive. Range is going to be, this is like the min. So
That's the min.
-3
With a bracket,
with the bracket
because
to
then take that
positive
on.
infinity.
You got it.
Okay, gotcha. Okay.
All right. Well, it
Yeah, that
probably
was
does it for say. I'm getting super busy. So if you ever need a lesson and you don't see anything available, just text me, especially if you got availability, earlier in the day. I can definitely
okay.
accommodate you. But that is it. Hope you have a great Valentine's Day, and I'll see you next time, whenever that
You
is.
too. Thank you so
Okay.
much.
You're
Bye-bye.
welcome. Bye now.